Hello everybody. Today I'm going to show you how I'm able to take an old monitor, like the one you see here in the middle, and turn it into a digital frame. I was looking for digital frames to put my QSL cards in, but they seemed too expensive, so I thought, well, I have a monitor and I have some Raspberry Pis laying around. I'll see what I can do. So I'm going to use this old monitor to display my cool QSL cards that I receive on this screen, so I can see them when I'm in my shack or at the radio, or show off to visitors when they visit. I haven't had any visitors yet, but I'm ready to show off. So I'll go step by step so you can do this too. The first thing I want to do is get a shout out to creator of Dynaframe, and this is only possible by a program called Dynaframe created by Joe Farrell at a YouTube channel called Geek Toolkit. It runs on a Raspberry Pi 2 or 3 and even Windows. It took several weeks and a few attempts at other programs before finding Dynaframe, but this is exactly what I needed for this project. The first item you will need is a used monitor. The one in the middle here is the frame that I built. It took so much trial and error that I couldn't really replicate it for video, so I ended up buying another monitor at Goodwill for $6. Unfortunately, the new monitor has lines in the screen, so I'll attempt to fix the monitor after I document the video, but I want to apologize first for all the pictures I had to take on the monitor with lines in it. Obviously, the better the monitor, the better the project. I needed another used monitor so I could retrace the steps I took to get the first monitor done. It was a lot of trial and error, as I said. So in this video, I went through the steps a couple times just to make sure that I could get it all down and document this. This video has taken me a long time to get together, so I hope you enjoy it. So, items you'll need is a used monitor with cords, spare monitor somewhere, SD card, Raspberry Pi, that goes in the Raspberry Pi. You'll need the power cord, video cord. In my case, it was a VGA cord, and I needed a VGA to HDMI adapter, a USB drive that you're willing to erase, and if your Pi doesn't have Wi-Fi, a USB Wi-Fi adapter. You also need a temporary mouse and keyboard for the Pi, and you also need a standard extension cord so that the unit only has the one cable to plug in when finished. Oh, and some double sticky tape to hide all this behind the screen. I got the monitor at Goodwill for $6. The HDMI to VGA adapter is $8 on Amazon. Regular extension cords can be found for $4 at Dollar General, and added a $2.50 RTL 8188 Wi-Fi dongle. If you need to order one, I recommend the CanaKit, which includes everything: case, card, power supply, heat sinks, the whole works, and a bunch more you really don't need. It's $120 for the Pi 3B Plus. If you're like me, you have all this laying around except for the monitor I had to get from Goodwill. The link for the CanaKit is in the description. I added copper shims to the add-on heat shrinks that I get for the Raspberry Pi. I was tempted to try quarters, other metal that would fit in the heat shrinks, maybe add an actual fan, but it's highly recommended you add extra heat protection to your Raspberry Pi. This little video shows my extra shims are not enough. What I will only refer to as a QSL ransomware image. I'm going to go on a rant, and here's my rant. And it's not even related to this project, but I just got to get it off my chest. This is something I abandoned a long time ago. I call it the QSL card ransomware package. In my opinion, this QSL ransomware breaks the Raspberry Pi Foundation's trademark guidelines with its logo, and more importantly, it breaks the GPL license terms. The GPL states anytime you redistribute, the recipient automatically receives a license from the original licensor. However, and I quote, "You may not impose any further restrictions on the recipient's exercise of the rights granted therein," unquote. This QSL ransomware package nags the user for a QSL card, and when idle, the ransomware runs Blink, which is a program that downloads scientific computing jobs and runs them invisibly in the background. Both these items are the further restrictions as outlined and demanded by the QSL ransomware. Look, when my computers don't run what I desire, it's classified as a virus or malware, and since this nags for something of mine to remove unwanted items, I call it ransomware. So here it is. Here is the QSL ransomware image overheating my Raspberry Pi, even with the added shims. And surprisingly, even after removing the further restrictions of Nagware and the Boink program so I could enjoy the GPL software's original terms, it's still overheated. So this QSL ransomware package has some serious issues. I think there is options to remove these programs in later versions, but I never really looked back. I'll install the Pi OS and add my programs from there. If you want my QSL card, you have to find my station on the air like everyone else. And it's pretty rare DX. Well, it's not DX, but it's pretty rare. Anyway, good luck and God bless. This project's not for me, and this is the end of my rant. Thank you for listening. You know, that was just my opinion. You may like the thing. It may work for you. I don't know. Just didn't for me. Anyway, so take something useless for me, like this QSL ransomware, and delete it for this awesome project. You will want to download Belena Etcher, found at the belena.io//etcher. This program will format and write images to your SD card. This is pretty well documented online, so I won't go into it. But after it's installed, you want to download the Raspberry Pi OS with desktop and recommended software. It's at https://. You're not going to make me read all this, so it's on the screen and it's in the description. All these steps are in the descriptions. At least that is the current file is the date I'm putting the video together. And this way we can install what we want or add our software that we want onto this image, and we can avoid all the other programs anybody else would think we'd want. Plus, we also learn to start with and learn the Raspberry Pi OS from scratch. So let's get started. Once this boots to the first start, you'll want to hit next. I wish it was that easy or simple, right? But next you'll have to pick your country, the language, and time zone. I changed my password to password, or I think it was root. Obviously yours should be different, and it should be as unique as you are. Follow the prompts. Set up the Wi-Fi, then update the Pi. And this took a while for me, but when it says up to date, you want to reboot it. Now you may want to change the hostname to something different besides Raspberry Pi, like CardFrame or ShackFrame. I called mine QslShow. It really should be the room and what it is. So ShackFrame as opposed to the living room frame or the left frame, or, like where and what it is. So you want to go to the menu, go to Preferences, then Raspberry Pi Configuration, change the host name here. Also click on Display, this Display tab, and disable screen blinking, and this will allow the Pi to keep the screen on so we can watch the show. After this is another reboot. So at this point you want the Pi to be online and surfing like a good little computer it is. At this point we want to put the USB drive in, and the first program that I'm going to install is based on a silly notion that an operating system should allow me to manage and configure disk drives and media. This OS doesn't make that easy, so I'll go to Add Remove Software and download a great program called Disks, found by searching for gnome-disk-utility. Once that is installed, we will want to run it after we have the USB drive plugged in. So plug it in, baby. Run the disk program. Make sure you select the USB drive in this program. It's on the left-hand side, the bottom drive. In my case, it was the one at the bottom. When you delete the USB partitions so that we can have an unallocated space. Once we delete those partitions, we name the partition and select, we name the partition and check that it will be used for all the systems and devices called FAT. So when done, we're going to note the device name or location or whatever that's called, or both. Notice here that mine in the screen, when I first did it, I left the two partitions there. So the third partition that I had formatted was dev/SDA3. Yours could be SDA1 or 2. Later when I redid it, I erased the whole drive. And when I did it, it was just /dev/SDA with no numbers. But you'll want to note what yours is. This is important later. Next, we're going to mount the drive, and we can do that with this disk program, but we're going to want to do this more permanently at every boot. So with the terminal window, and that's at the top here, you want to type sudo nano / let me read this again. You're going to want to type sudo space nano space /etc/fstab, I think. Remember when I said we would need the dev SDA3 name or that dev SDA, or if there's a number? Here's where. We're going to type that from the other program, for, in my case, /dev/SDA3 space. Now I'm going to mount this in the mount folder. I think that's the mount folder, MNT. And I'm going to name the folder my picture. So it's going to be, with that space, it's going to be /MNT/my pictures with the M and the P capitalized. Then space VFAT space defaults, comma, umask equals 000, comma, no fail space 0 space 0. Now this is going to be hard for me to say, so it's going to be in the description, and you can copy and paste all these things so you can add it to yours. Or you won't be able to copy and paste it, but you'll be able to take a picture of it or something, or maybe even print out the description. How's that? Anyway, I can't keep saying all the forward slashes and all that as we go through. With this command, the USB partition will be mounted in this directory with this folder name, and will help us not have any permissions issues later on. When done with nano, we will Control X, type Y for yes, and hit enter to keep the file name the same. We're going to do this a couple more times. When we're done, when it exits nano, we're going to type sudo reboot at the terminal window. Okay, I just realized I wasn't saying the number of the steps, so I'll put that in the video. But basically, we just completed step 10 and step 11, and now we want to check our work. At step 12, after this reboot, we're going to go into the file manager at the top, navigate and click on MNT, that folder there, and then we're going to right-click on the My Pictures folder, select Properties, then select the Permissions tab. Now all these should read Anyone. This is checking our work. If all these permissions don't say anyone, then we're going to go to repeat step 10 because something was mistyped there. We need that to actually, all that, including you probably typed unmask instead of umask, or you put a space in whether after a comma or something. But I've done that, and it's taken me a couple hours to realize that that wasn't matched. So those didn't line up, and so if you don't see anyone on all three of these, that line was not correct, and we need to go back and correct it. Okay, and keep in mind step 10 and step 13, when we're getting ready to do, is probably the hardest things I had to do to get the Raspberry Pi to act like I wanted. So next we're going to create our Samba share. This is number 13. This will allow users from the network to get to this folder and add or delete files, in our case pictures of QSL cards. So let's get back to the terminal window. Type sudo space apt-get, apt-get, install Samba, hit enter, hit Y for yes, and afterward we're going to type in sudo space nano space /etc/samba/smb.conf. Once opened, we're going to arrow down to go to the bottom of this document, and without erasing anything at the bottom, we're going to name our share, and I called mine frame pics. This should be in square brackets. We're going to hit enter for the next line, and then tab key for this path equals. And again, this is all in the description, so you can copy and paste, or just, like I said, print it out and so you can type it in. But it should match this. It should be the frame pics in square brackets, and then everything else tabbed over. And once you get done, in Nano, we're going to Control X, Y for yes, hit enter to keep the same file name, and now when that's done, we're going to again sudo reboot. After this starts up, we should be able to navigate from a Windows or any other computer on the network to this drive and create or delete a folder at this location. So basically we're going to go to Windows, open File Explorer, and type in the address bar // and then your host name. For mine it was QslShow. So if you hit enter, it should go there, and you should see a folder called FramePics. We're going to double click on this folder and then right click to create a new folder inside it. After you create that new folder, see if you can delete it. If this was good, we're ready to move on. But first, let's add a few pictures here. Any picture, JPEG, PNG, doesn't matter, I don't think. I think it does quite a few pictures. You just add a bunch of QSL cards. There's pictures of that in this folder. All right. For me, adding this USB drive on the Raspberry Pi and making it shareable on my network was one of the hardest things I had to do in this project. So if you follow my directions and you didn't get the same results, only the Linux gurus can help you. I'm a Windows guy, and Linux, it seems, is 99.9% about permissions. It honestly all confuses me. So I hope this worked for you. Before I did this video, I did rebake my Raspberry Pi with the same recipe, just to make sure it works and to create this list in the description. If yours doesn't work, then try it again, watching for syntax and in the right order. The reason I need to have this photo shareable in my network is plenty. I need to scan QSL cards as I receive them straight in the scanner to the Dynaframe folder. Plus, I can copy or move pics downloaded from eQSL or other logging sites online, or a folder from a logging software. Anyway, I'll show you this in a bit later. Now I'm ready for the easy part, Dynaframe. I want to install the latest stable version, which is 2.19. Joe's working on a Dynaframe version 3, which should be out pretty soon. Keep in mind this frame does a ton more than I'm using here. It's set up to use MQTT and home automation access for total control of these screens. I used to use Home Assistant for home control, but then I just started using Amazon's device called Alexa. Play Baby Shark. That took me, I don't know, 10 minutes to stop that stupid thing. Alright, you're back, because I'm going to do it again. I guarantee I'm going to do it again. Anyway. I hate when people do that. Here I am doing it. I'm so cruel. Where was I? Oh, yeah. I started using the Sheila. We always say Sheila when we... It's crazy how they did that. They made it the same name. You can't even talk about Sheila. Anyway, I started using Sheila and stopped using Home Assistant. So I now have a free Raspberry Pi for this project. Anyway, Dynaframe is awesome. You can have multiple screens work together in sync to show movies and pics related to one another. Truly incredible software. It really is a media experience. Joe's told me in an email that Dynaframe 3 will have a redone web page and a bunch of other community fixes. He's also working on a web-hosted site so people can easily download content for their new version. Perfect for those wanting to show anime and comic pictures or movie posters. Soon he will have a Patreon subscription for donations and a subscription available for more supported model of the frame. Exciting things to come for the software for sure. A great video to watch is his update video that he has on his YouTube channel, so you can see what it is capable of. Keep in mind that the video he has is an even earlier version of what we've installed here. So the link to it will be in my description. Plus, I'm a newbie YouTuber and I don't know how to do the linky thingy here or here or here. Just trust me, it's down in the description. In the Dynaframe video, he shows you how to install Dynaframe, but I'll do it here so that we install the 2.19 version. That is the most stable currently. So basically, we're going to go back to the Raspberry Pi, go to the terminal, and type in sudo space wget Alexa, play Baby Shark. Actually, you thought you were clever because you used Echo. Play Baby Shark. I gotcha. Anyway. I'm so evil. Anyway, this is in the description. It will reboot. You're going to wait a bit on the home screen, and then it'll go to this black screen to show Dynaframe is running, but it doesn't have any pictures. Now we're going to do two things here, and only two things. First, and this is really important, only hit escape when Dynaframe is running. Hitting another key other than escape doesn't seem to work for me, causing me to have to kill the power to get back in. So only hit the escape key, and it'll exit Dynaframe, and you'll be back to the home page, the main page. Second thing is we're going to navigate to the Dynaframe folder. So we're going to go to the file manager. Once we get to the Dynaframe folder, we're going to scroll down to a file called run.sh. We're going to copy and paste it to the desktop. More details are in the description. This way, when we hit escape to stop the Dynaframe, we can execute this script to get it started again. I know it seems weird, but I needed this since I might actually want to use my Pi as a computer too, and then when I'm not using it, I can start Dynaframe again. And that's why I installed the fresh Raspbian OS after all. Before we start Dynaframe back up, we're going to mouse over to the wireless icon at the top right, and we're going to note down our web address. Keep in mind we probably won't need this since we'll be using the host name, but it wouldn't hurt to have this address. Now double tap the run.sh file we created, choose execute, and get back to the Dynaframe black screen. Now go to another PC. Navigate to the address, in this case mine was 192.168.254.179, and add a :8000. Again, I would recommend you use the host name instead. Reason for this is because this IP address could change if you restart your Pi or something or change your network, but the host name should be the same. In my case, it was QslShow and then :8000. I like this instead of the address. You should end up at the Dynaframe page on the Raspberry Pi. At this page, the second tab at the top is the Playlist tab. You want to click it, and this is where we list all the different folders and playlists that the frame will look at when it's starting up to create its own playlist to show. We need to add our USB folder that we created. Below at the Add Directory box, we want to put in /MNT My Pictures, and then click Save. You should see that folder at the top under the playlists. Now we want to go back over to Controls and click the Update File List, and then click Next under the slide controls. You should see a picture on the Dynaframe. Then we can click on Shuffle, or we can click on Settings and have some fun. For my frame, I changed the transition duration during fades to 3000 from the default 1600. I never could get my IP address to show when I installed it my way, so I disabled this from a 10 to a 0. You can just change that 10 to a 0, disables it. I changed my aspect ratio to fill. You may want to leave this. It's your settings after all. Most of the settings take an effect on the next picture, and some are when it's rebooted. Ta-da! You now have a QSL cards on display, in order or in random. There's no need to tack them to the wall or put them in a picture folder or make up binders. You can now organize your original QSLs by year and by call, and yet still see them digitally shown here 24/7. And it doesn't overheat. I tell Sheila to turn on a group called the Shack, and my frame turns on with some other lights and appliances. Oh, and here's me scanning in some new cards for the digital frame I got recently. I mapped the folder as a drive on my laptop so I could use the scanner software to drop the scan straight to the folder. The scanner's on the other side of the room, so I take my mouse with me and set it next to the cards, and then I go back to the laptop and use the trackpad on the laptop so that the mouse pointer is at the right spot. Then back at the scanner, all I have to do is place a card and click without moving the mouse. If the back of the card is fascinating, I'll flip it and click. If not, I'll replace the next card, click. Easy peasy. Next time Dynaframe starts, these pics are added, or I could click to update the file list I've shown. You see me here acting, so you know why I just post pictures and now voice over. Anyway, I hope you like it. I hope you add all this to your old monitors, at least to a nice monitor for your shack. Now I gotta take apart this monitor and try fixing it. Donating it back to Goodwill just doesn't seem right. Oh, that's not it. That's more like it. Here, let me play it for you.